Do it's Chemdork.
Hello everyone, this is Chemdork, and welcome to episode number 48 of Season 2 of my Buildcraft, where we play Minecraft with the mods Buildcraft, Thermal Expansion, and Forestry. Welcome guys to 2015, this is the very first episode of the new year, hooray! Hope you guys had a nice holiday. I've been a little sick for the past few weeks here, so just sort of getting over that. So, haven't had a time to record, and haven't really felt like it. But now I feel like recording, and let's get back into Minecraft, because we have some stuff to do. So today we are staring at what used to be the quarry. It's kind of, this is where the quarry, there is a quarry down there. It's not like a but it's a non-functioning quarry. Just because I haven't hooked it up to power, didn't really do that. We might do that this episode, but this episode will be dealing with power. So here we are in the power control room of sorts. We threw together these buttons, and they do stuff. We can turn it off, which is what I'm going to actually do. So that turns it off immediately and drains all the items out of the system. And we devised this system where we put up these buttons to control the power. There's a little lag when it does it. But the buttons here weren't really the point of the whole thing. This is not the point of the whole thing. I like this increase, decrease by 1 power level, but the 2, 3, and 4 are just here because we can. And I may not keep them because I don't always use them. The plan, however, for this power plant was that we have this power control room, where we have a readout of what the power plant is doing, but we set up the decoder system so we could devise a strategy for sending a signal down to my power plant and telling it what to do. Let's go ahead down here and just kind of go over the system very briefly, because it's been a year. Haha. Well, it's been last year when we did this. Down below me is a decoder system of sorts. Basically, it's just out of the series of red, yellow, green, and blue pipe wires, a specific combination of them is decoded in one of these underneath these pinkish or magenta and green blocks. There are pipe gates, and those pipe gates decode specific combinations of wires being on and off to indicate different things. Anything on the green side is adding power, anything on the pink side is decreasing power, and they're decreasing power by a certain amount of power level increments. And the reason why we have this set up is not so that the buttons can talk to this, but so that all the other things in my base can talk to this. Because certain things, such as what you saw before, which was the 3 power levels, that was what my assembly table needs to have turned on, and then if I want the assembly table on but something else on as well, I need to add a certain amount of power, which may be 3 power levels in addition, or it might be, 1 more power level on top. So if I'm running the assembly table, which needs 3 power levels, and another machine that needs 1 power level, in total I want 4 power levels to be on in my power plant, and that's going to be allowed with this system down here. Because it will allow me to sort of adjust on the fly and have things either automatically update or be manually controlled. So we're going to set up 2 different ways of telling this power plant what to do. The first is, it's all going to use these signaling pipe wires to do it. It's just a matter of what conditions will tell those pipe wires to send the signal. And they're going to be 2 ways of doing it. One is going to be manually controlled, so assembly table, it's going to be a manually controlled thing in my base. I'm only going to want this on when I'm here, because then I can decide what to make and yada yada yada, so it makes sense to have this manually controlled. Certain other things, such as maybe some of these not really currently in use, but the machines here, as you see, they are going to be automatic. So when in this case, when my induction smelter here is in need of power, it's going to ask to have power sent so that it fills it up. And that's going to be an automatic thing. So I'm going to have to set that up to do that, and I can do that. Well, it's going to be a similar way we do that as we do the manual, but we'll do the manual first. So for the manual setup, and for some of these machines, we're going to use these Emerald Kinesis pipes. So I'm going to throw them down right here. So in this case, the Emerald Kinesis pipe, we're going to put one right here, and these act as switches that you can control with pipe wire. So let me grab some pipe wire. Actually, I don't have any, and actually I don't have gates either on myself. For this, I just need actually two gates. Yes. I need one gate and one iron gate. Iron ore gate. Yes. Okay, perfect. And then I need some pipe wire. I'll just take some red. No big deal. Okay, so we threw down an emerald pipe. It doesn't really do anything at this point, but it can be controlled by gates. So we're gonna throw down an iron gate. Just throw some red pipe wire in here. And I'm going to run the red pipe wire to here, and this torch right here represents where the what's controlled by that switch. That switch is now down, which is actually powering this block, which powers off the torch, but this is reading a redstone status signal of off. When it is on, that means the switch will be up, my system will be on, and I want the pipe wire to be on. So I want redstone signal on, pipe wire on. That means the system is on. And that's all connected here. Okay, and then we can connect it here. So that means if the pipe wire is off, it means the system is off, and I want to have this state be closed. If it's on, I want the state to be open. And that means that when it is off, no power flows through here. When it is on, power flows through here. So when this red pipe wire signal is on, power is going to be allowed to flow through this pipe. Let's test it actually right here. We're just going to send a little signal. Come on. So let's turn on. You know what? Let's turn on 2 power levels. Okay, a little lag when we do that, but that's okay. It's a lot of the pipe gates and pipe wires updating. And we should be getting some... Okay, so power is flowing to the system. That's 1. We'll see 2 in a minute. Hold on. Should be seeing 2. There's the 2. Okay, and I think that's only 2. We might actually power 3, but we never know. Okay, so it's not on. This thing is not on because no power is flowing, and no power is flowing because this is now currently in a state of off. Right? The status is red pipe signal is off, so this is now closed. No power can flow through, so no power flows through ever. If I do that, power starts flowing, theoretically, and there it goes. And there we go. So that works. Alright, so that's great. It's good to know. But that's not all of it. See, we want this to control the pipe wire, or rather, we want this to control the ability to send a signal. But the second part of that is we want it to also send this indication that the power plant should either increase or decrease the amount of power flowing to it. So I'll turn off the system. That's for the time being. Yeah, we do get a bunch of lag when I do that. This is not optimized for lag. I should say, this power system, just to reiterate, I've said this before, it is made to be complicated because I love complicated things, and in some cases I like to overcomplicate. The point of this was to challenge my mind and make it more fun for me to do this, not necessarily to make it the most efficient thing ever. I want to see how far I can take this in terms of just kind of using mostly Buildcraft things in here. Okay, so anyway, the second part of this involves some special redstone stuff. So for that, I think we should actually... Oh, weird. For that, I think we should actually travel to the creative world. We'll travel there with the magic of video editing, and where we'll talk about some redstone circuits we're going to be using today in this episode. Okay, see you in just a minute. Welcome, everyone, to the creative world, where it is time for another
Redstone lesson of the day.
Yes, indeed. It is time to learn a little bit about redstone. We do these every so often, and I decided it's a good time in this episode because we will be learning and using extensively one circuit that we don't use too often. So we'll be using 2 circuits in this episode predominantly. One which we know very well, and that's here over on the left. This is an RS NOR latch. It is a 1-bit memory cell that can exist in 2 different states. And the other one on the right here is called an edge trigger, and we've used these before. We actually use one in the power plant, but I never really went into too much detail. I thought it was a good time to do this in this episode because the edge triggers will have a particular highlight in today's redstoning adventures. But just to say a little bit more about the RS NOR latch, because of course we haven't said enough about it already, we use these all the time, but this is an example of, and I think the terminology is correct, an example of a bistable circuit. Sorry, it's a bistable circuit because there are two different states, this one and that one, for the entire circuit to be in, and each one of those is stable, meaning this will remain this way until it's triggered to go into the other state. It won't change and revert back on its own. We can turn this into a monostable circuit. I'm just going to make a decent monostable circuit here by linking the two together as such with repeaters. Any number will do, but this is one so I can show you for a brief time. When we power this side now, it is stable until it switches back to this side. So in this state, as it exists right here, it's stable, but this state is unstable. So this is why it's called now a monostable circuit. We've used these as well in the power plant, and we've used them in the past. So that's a monostable circuit. I don't know if you can actually call the edge trigger monostable either. I am a scientist, and I am not a computer scientist. I'm a chemist. So I don't know if the terminology here is correct. The terminology for this is definitely monostable circuit, because it is correct. I don't know if you can call an edge trigger a monostable circuit or not, but essentially it exists in this state with the torch being off. And instead of like other circuits, the edge trigger is a little bit special, because this is the input line, and that's the output. With a lot of circuits, the input line, whether it being on or off, dictates what happens to the output. In an edge trigger, it's not the actual state of this input line, but it's how this input line changes state that triggers an action. So in the case of this is a plus edge trigger. It is triggered by changing the state of this input line from off to on. So when we do this, you'll see a pulse is sent out of that output torch. And now the input line is on, so it's in an entirely different state as before. When we turn this from on to off, though, nothing happens. And again, when we go from off to on, it sends out a pulse. On to off, nothing happens. So this is one example of how you can set up this circuit. This block is needed in order to power this line, and these two repeaters, if you extend this portion out, you can actually extend the length of that pulse. But we're going to build a different design of an edge trigger just to show you the other different designs. I think I may end up using this vertical design in the end. But another design is, well, I can show you right here, as we demonstrate how this is useful for today's episode. So what we have and what we just saw before when we were in the real world was the switch on the wall by the assembly table. And when we turned it on, we set it up already to allow power to flow through an Emerald Kinesis pipe. When I turned it off, the power stops flowing through that pipe. What we want to also do is link the state change of this lever to sending signals. In the case of turning it on, we want to send a pulse. We want this to trigger sending a pulse that will tell the power plant to add power levels to the power system. And when we go from on state to off state, we want to trigger that action of taking away the power levels because we no longer need them to power the assembly table. So the edge trigger is actually a perfect circuit to use for that purpose. So here's the input line for both of them, and I'll show you essentially how we're going to set this up. So in order to build an edge trigger, I'm just going to make sure I have enough room for everything. I think, yeah, this is fine. We'll start it here. Yeah, we'll start it here. So it's essentially going to be building, we can build this, or we can build a different design, which is what I'm going to do here. Instead of being in a vertical fashion, this is kind of in a horizontal fashion, but it is basically and it kind of shows you the workings of this a little bit more. So this is exactly the same as this, only kind of flipped on its side. So that you have one side which is inverted from the input signal. The input signal is this, right here, right here. One side which is the same as the input signal but delayed. So we have the same thing over here. This is the input signal. This side is delayed but is the same phase as that input signal, the bottom. And then this torch inverts the signal, and you see on the top of all this is the inverted state of that signal. So you have the same thing just turned on its side, and you can kind of create your own design, but the same principle just holds true. So this will function the same way that the other one did. When we turn this on, we'll see a pulse, and when we turn it off, we don't see a pulse. Got it? Cool. And then, like I said, you can actually just invert this input signal in order to get the opposite, and we're going to do that here. So right next to it, I want to make sure I actually leave enough room. I think that should be enough room. Yeah, it should be fine. We're going to actually invert this this signal, so we'll do it here. There we go. Put a thing there. I actually need to, whoops. I actually need to change the state of this, right, just like that, so we can see it still. There's the output torch. There's the inverted signal, and there you go. Okay, so there's the same thing. Now let's invert this input. We can do it by either doing something like this. This will work. Or we can do it by something like this, which I think is a little more elegant, like that. So that should work. Okay, so when I turn this on, the far line is turned on, is pulsed once, so let's do it again. And when I turn it off, the close line is pulsed. So we have signals sent for the two different states that we want changed. So not only does this control the Emerald Kinesis pipe, this is going to control, in this case, it'll ask the power plant. This will trigger asking the power plant to increase power levels. This will trigger asking the power plant to decrease power levels. Cool? Cool. Okay, so that's today's Redstone lesson of the day. Let's put it into, well, let's put it into practice. Okay, be right back. Okay, we are back, and it's time to set up our little edge triggers. So, this is the torch from the switch there by the assembly table, so we'll use this as an example. And so one side is going to be the same side, or the same phase. This is going to be the add power level. And the other side is going to be inverted. So we're going to invert this one. And there you go. So I'll just build the edge triggers from this. We'll just build them this way, I think. There you go. Right there. And this one will be the other guy. He'll be the inverted dude. Right there. And torch there. Torch there. Build them here at the same time. There we go. And this one is... there we go. Okay, so then the torch here and the torch here will pulse in two different states. When this torch turns on and when this line goes from off to on, this torch will turn on and pulse briefly. When this line is from on to off, it'll essentially do the opposite, which is have this torch pulse briefly. Okay, and then what we're going to do is set up gates here in front of these two to send to the same to the pipe wires. So I have to look up actually which pipe wires I need to turn on and off, but then I'll hook up these and connect them to this line right here. This is the main line that goes down to all these decoders. Okay, so I'll be right back. All right, see you in a second. Okay, the final piece of this puzzle has been put into place. So I've run these wires now and set up the gates so that when this torch turns from off to on, it will turn on this redstone torch, which will send out a green-red signal. The green-red signal will tell the system to add 3 power levels. When this torch goes from on to off, it will send out a pulse from this torch, which will send a green-blue signal. The green-blue signal tells the system to decrease by 3 power levels. So 3 power levels is where it should be. I'll turn this on, and that will change the state of the Emerald Kinesis pipe and send the signal. So what you saw there was a residual power from the system coming out, indicating that the Emerald Kinesis pipe is indeed changed. And now we're getting power. Cool. So let's see what the status is, or the state of this is. I can see 1, 2, 3 of these are on, so it's on by 3 power levels, which as it should be. Now let's turn it off and see if it works the same way. That'll change the state of the Emerald Kinesis pipe and also change the power levels, so these should go down. It's going down to 2, and then 1, and then hopefully, theoretically, there it goes. Perfect. All right, cool. So that's the first step is manual. So manual signaling is all done. I just do this for whatever other systems I want to be manually controlled, and we're done. Now it's time to set it up for an automated case, because sometimes we have a lot of machines here that I don't necessarily want to turn on and off. Maybe these guys and maybe some other ones. Maybe this automatic resource regenerator is actually a good one to use as an example. All of these machines back here, I want to turn on automatically because it's supposed to be automatic, right? So when this guy, the redstone furnace, is getting low on energy, I want it to say, turn on the system, send me some more signals, send me some more power. And in order to do that, I need to hook this up to pipe gates and pipe wires and such. But we're going to have a little bit of a problem due to how pipe gates and pipe wires work. We're going to do some experiments and see exactly how these problems might manifest. And we'll go in the creative world again and do a little experiment. Okay, see you in a second. We're back in the creative world to describe a little bit how the automatic system's going to work and a little bit of a hurdle we're going to have to overcome in terms of how we're going to make it work with our power plant system. So the way our power plant system works, again, is we need to send a specific sequence of pipe wire signals in order to tell it to either add or remove a certain amount of power to the system. So when a certain thing like a pulverizer needs power, I want it to initiate a trigger. That need for power is going to trigger adding more power to the system, and then when it doesn't need power anymore, it's going to trigger removing power from the system, and that's indicated by these two states here. So needing power, it's when you... let's look at the gate. Power requested, that's the status. Now, unfortunately, there is no status for power full, so we're going to use power requested. Here's a full one, where that power requested is not true now anymore. So we're going to have to use that as our trigger, so that when it turns on, it'll send out a pulse, and when it turns off, it'll send out a different pulse that removes items. Okay, it kind of makes sense. It's sort of like this, where our triggers were... this turning on sent out a specific pulse to add power, turning off sent out a specific pulse to remove power. So we're going to use the same thing here. I'm going to try to connect as many machines together as possible so that they are all linked to the same sort of request signal. That way it kind of eliminates the possibility of requesting power, not requesting it, not requesting it, and sort of that sort of thing. It's going to be like that. I'll show you how it's going to work in a minute. So machines that are close together, I think, and linked up together, I'm gonna connect together. So anyway, over here is a little bit of a demonstration of it. It also demonstrates a little bit of a problem that we run into, and this problem is run into when you have long pipe wires. So this is going to be the general setup up to here, right? So this is, if you recognize it by now, this is now an edge trigger. This is a plus edge trigger. So that when this pipe wire turns on, it's now set up so that if power is requested, it turns on a blue pipe signal. And here it's if the blue pipe signal is on, send out a redstone signal. So when this redstone signal turns on, when it first requests some power, it will send out a pulse here. And that's the reason why I have this RS NOR latch, is to just help us identify when a pulse has been sent. Remember, this is a memory cell, so it will remember the state. So when a pulse is sent, it'll turn this side on. So let me just actually do it by removing this and placing a blank one. It sends a pulse, and now it's remembering the state of, oh yeah, you needed something. Yeah. So that when this turns off, if we hook it up to a minus edge trigger, we can also have a different pulse sent out to do what we did over there. Okay, that makes sense. Now what happens when you have the same setup, just longer? Well, it's gonna work the same, but the problem we run into is, what happens if we do this? And then we do this, and we load it back up. Does anything change? Now in the case of this setup as it is, it doesn't. However, this is kind of at the edge here, so if we do something a little crazy, and what I mean is if we do something a little crazy like this, we're gonna extend the amount of blocks here that the pipe wire is going. This is excessive maybe, but it's not unrealistic to what we might have done if we were just not as concerned about this. But right now I'm going to show you what happens when you extend the pipe wire to a decent amount. And this is kind of random in terms of how long it needs to be. So we want to minimize the length of our pipe wire signal. So okay, we'll reset this RS NOR latch. So now what happens when we exit and re-enter once again. And you'll notice, uh-oh, this switched. So that means that we exited in a state where it was requesting power. We exited the world, and then we reloaded again. In this setup, if this were the setup, if the signal had to travel a long distance, the pipe wire signal had to travel a long distance before it hit the plus edge trigger, it would have requested again the same level of power if we unloaded and reloaded the chunk or unloaded and reloaded the world. That's a problem. So we need to make sure we limit the length of the pipe wire. Now, the question is, why is this a problem? Why does this happen? And the answer is really quite simple. Pipe wires don't load in the world in their on or off state. They don't remember the state they were in when you exit or unload a chunk. So when I do this, this pipe wire has no idea it was on. So it's going to reload into the world in an off state, and you might just catch it. You might have just caught it there. It was like a little bit of a frame, but it was off and then it turned on. And that's how pipe wires work. Now, certain times that delay of turning on isn't really enough to warrant sending out a signal. But other times it will do things like trigger this once again. So we have to, in order to avoid this, we have to just limit the length of pipe wire. And what I found is that 8 blocks or less is really enough to eliminate that delay, although it's kind of on a case-by-case basis. You kind of have to test it out. So I can do that on my own, but I'm pretty much going to limit to 8 or less blocks. I've tried a few different setups, and it seems to be around there. So this is like 6 blocks. We're going to keep it to very minimal, as much as we can, minimize stuff. So I'm going to go in the world and go through a few setups here, and I will be right back. So this is what I am envisioning. So each of these machines here has next to it a little gate that is asking if power is requested, turn on this red pipe signal. So this red pipe signal is linking together a bunch of different machines. If any one of them is requesting power, it will turn on this red pipe wire, which will send out a redstone signal. This is 10 blocks long, so I believe this should be okay in terms of the updating issues that we see. So if we go down here, we have this room which will eventually be hit with redstone, and we take this signal and put it all the way over to here, and we actually need to link it up to this line right here, or essentially eventually this line. I'm going to go ahead and do that. That's the boring let's run the signal type of things. I will set up the edge triggers right here and show you the result. So see you in just a second. And here we are. In this case, we're using the vertical versions of the edge triggers. So the one over here, this is the design for what happens when the signal turns on. For turning on, the trigger is going to be send out a red pipe wire. And the other one is the same exact design, except it's inverted. So it means it's the turn off one. So this one flicks and is turned on when the signal is turned off. So that, yeah, that's what we're going to do. So we're going to set up these lines, and we're hook them up directly here. And the only reason why I'm doing this is to just limit the distance this redstone signal, this pipe wire signal, I should say, has to travel. And so the nice thing is, okay, so this one is the turn off. So that is a blue pipe wire signal. So it's real easy to set up. When it gets a redstone signal, just put out a blue pipe wire signal, and the basic gate is all you need for this one, because when it receives a redstone signal, we're going to turn... Come on. Oh, wait. I need pipe wire. We're going to send a red pipe signal. Okay, and then I just combine these two into one and hook it up to... I can actually hook it up right to here because there's a red and blue line already there. So I'll do that, being careful to avoid this one right here. So I'll need to hook it up just like this. And this should... Whoop, get away. There we go. This should do it. Okay, so I'm going to do it right like this. And I'm actually going to bring it up a little. Oops. I'll bring it up. Come on. Bring it up. No, I won't. I don't want that to interfere. This is where it gets kind of screwy with the all these pipe wires and everything going around everywhere. All right, well, I'm going to hook up this up. Yeah, I'm going to hook this up, and then we're going to see it in action. All right, see you in a second. Okay, that's it. It's all set up. But the problem is there's no power running here. Why isn't there any power? Why isn't this filling up? Well, the reason for that is actually quite simple, and that is because this is currently on. Remember, it's hooked up to an edge trigger, which is only triggered by turning this on. It's already turned on, so we can kind of simulate turning it on by removing and replacing this redstone right here. Okay, so this will simulate sending out that pulse. There's a little bit of a lag, and the lag again is created really by really by the updating of all the pipe wire. The kind of pipe wire takes a while to update. So it's not traveling along, and I actually recall that there's a good reason why, and that's because it's not actually hooked up to the power system. So we need to hook it up to the power system by connecting it. Boom, there we go. Okay, there should be, there's some power running through it now. Yeah! Now it's actually filling up all of my machines, which is good, and I want to do that anyways, and I'm going to do that manually, but now it has been triggered to turn on by filling up all of these machines. So I'll essentially set that up for a few different stations. I'll probably set one up over here. It might be a manual method for this guy because I think I broke that when I was doing stuff underneath. But for the liquid processing, the same thing. I'm going to be here, and it's going to be a manual setup, I think, for the liquid processing, because if I ever do some liquid messing around, I'm just going to turn it on, and that's going to be fine. Same thing for the obsidian generator. I'm actually going to have a lot of sort of manual setups here, I think. But I'll put them in over time, and if not, I'll just have them all set up to the network here, and use the just use the buttons back here to fill them up. So right now it's only giving 1 unit of power, and there's a lot of engines. So let's go ahead and really kick this up a notch. In fact, let's kick it up 3 notches, and let's get a total of 4 units of power, supplying all of the power to all of the things in my base. This should theoretically provide a nice amount of power. So here we go. So cool, power is running to the base. I'm really actually quite excited. For the first time, for the first time in quite a while, my machines are gaining some power here at a decent rate, honestly. Not bad. So anyways, guys, it's been a really cool episode, the first one of the year, and we are finally getting power. That is really a good thing. This map reminds me, we still haven't really messed around with robots at all in our potentially new robot location. And we haven't gone back to the Nether and worked on the Wither skeleton farm. So we have a lot of projects going on at this point in time, but now I have all the setups I need for updating the power system, and it looks to be a pretty good year. So, thanks for watching, guys. I will see you in the next episode, where we will do something else, like we usually do. See you later, and take care. Bye-bye now.